Have you ever wondered how you can use a simple USB device to turn your Raspberry Pi or other Linux computer into an analog signal recorder / oscilloscope? Then this video is right for you. The things that you need for this experiment to work is a Raspberry Pi. I would recommend a Raspberry Pi 4, an AUTO INTERN OmnAIScope, and some form of signal source. I'm using this frequency generator down here. So I'm using my Raspberry Pi via SSH. So first of all, I'm going to log into my Raspberry Pi, including X forwarding. You see the -Y here, which enables X11 forwarding. Next thing is that we want to download the OmnAIScope data server, or the OmnAIScope executable. I did that already, and here is the command. So it's wget and then this URL. You will find the link in the video description. So I'm downloading it, and here it is. In order for us to use it, we need to make it executable. So let's modify the permissions, seeing that it now turned green. In order for you to access the USB, it might be necessary, depending on your permission setup, to use sudo when you are accessing a USB device. Let's see the -h command first, so you can see the help. And there are three commands that I want to talk about now. One is the search, one is device, and one is output. So first of all, let's figure out what the device IDs are of the attached devices. So sudo mini-omni-s, and you can see I have one scope connected. Let's take this UID and run sudo mini-omni-d, copy the device ID, and now we're using the -o option to store it in capture.csv. I'm starting the scope now, and I'm just waiting for a couple of seconds to receive data from my function generator. I'm stopping the program with Control-C, and now we see there is a file, capture CSV. Let's take a look at it. Capture CSV. You see, okay, here we have data in it. So great. Now we capture data with our OmnAIScope device. The next step now is to display the data. In order to do that, I will use a project that I already prepared on GitHub, or let's say gist. I will also put that link into the description. I'm taking the HTTPS link and I'm going to say git clone link, and we call it show data. So I'm cloning it into show data. Let's cd into show data. And you can see here there is a README, there are requirements, and there is the omniplot.py. Let's look into the README. Well, the README says everything that you can also read online. Just go through it, maybe if you download it, and make sure you understand everything that's written. If you have any questions regarding that README, just write them into the comments. So first of all, I always recommend when running Python to work with a virtual environment. So I'm setting up my virtual environment here, and just going to call it env. This takes a little on a Raspberry Pi. There's no problem here. When we run this, when we've run this, you can see that there is a new directory here called env, and we want to source the activate file. Now you can also see that it says env in front of our command prompt, indicating that we're now in our virtual environment. The next step is to install all the dependencies that are written down in the requirements.txt. Depending on your internet connection, this may take a while. I already cached all of the libraries, so that's quite swift here. Then, of course, it installs them. This takes a while. All right, so all of our dependencies are installed, and now we can run the actual plot script. Python omniplot, then -i, and we're going to give it the capture.csv file, run it. Also, loading the data takes a little on the Raspberry Pi, but you can see here we recorded this wonderful sawtooth between +10 and -10 volts. If you don't yet have an AUTO INTERN OmnAIScope, you can easily get one from Amazon or the AUTO INTERN webshop. I will provide the link in the description. If you found this video useful, leave a comment and tell me what you are interested in to do with the OmnAIScope, and also maybe check out my other videos. The OmnAIScope software is also available for Ubuntu and of course Windows. So thanks for watching.